factor each polynomial completely. Alright, so we're going to kind of add on to what we've done so far. And so now some steps that we want to sort of think about when we're factoring completely. Is there a GCF? Alright, second, after we factor out the GCF, are there 4 terms? Alright, if there are 4 terms, we try grouping. Are there 3 terms? If there are 3 terms, look at the lead coefficient and try our techniques for trinomials. Alright, and again, we'll add on to this as we progress. Alright, so exercise A, we have 6x squared minus 24xy plus 2xy minus 8y squared. So the first thing we want to think of is there a GCF? Alright, just sort of looking over this, I notice that they're all even, so it looks like I can factor out a GCF of 2. Alright, so let's do that. So I have 2, and I'm going to use brackets here. I'd have a 3x squared minus 12xy plus xy minus 4y squared. I see 4 terms, so I'm going to try grouping. So I'd have 2, bracket, and in my first group I'll have the 3x squared minus 12xy, and in my second group I'll have xy minus 4y squared. Alright, now finding the common factor for the first group. Let's see, that's 3x. So I have 3x by x minus 4y. My second group, I can factor out a y times x minus 4y. Notice that I have that common binomial factor. So I can factor this as, let's see, 2, and then I'd have x minus 4y. And my second grouping would have 3x plus y. And usually we get rid of those brackets, so I would write this as 2 by x minus 4y by 3x plus y. And I could check this, but just for sake of space and time, I won't check it. Alright, exercise B. 5x squared minus 5x minus 60. First step is GCF. Is there a common factor? Yes. 5 is a common factor. So I can write this as 5 times the quantity x squared minus x minus 6. So now, looking at that trinomial that remains, the x squared minus x minus 6, notice that my lead coefficient is 1. So I don't need to use AC, I can just use the inspection method with b equal to -1 and c equal to -6. Thinking of the factors of -6, let's see, I'd have -1 and 6, or -2 and 3. So let's see, that gives me a sum of 5. -2 plus 3 gives me a sum of 1, but I need a sum of -1, and so that tells me I need 2 times -3, and 2 and -3 have a sum of -1. So that's the pairing that I want. So that tells me then I can write this as 5, and then I'd have x, and I'll write x plus 2 by x minus 3. So I have 5 times x plus 2 times x minus 3. Alright, and let's see, we have -12a squared b plus 52ab plus 40b. Alright, so let's look at this. Notice how I can see that there's a common factor of b, and notice how also there's an a square a, and then and the last term, there's no a term. So we have that a square a, and then sort of constant in terms of a. Let's see, what else do we have? Everything's even, so that means I can take out a 2. Oh, but in fact I can take out a factor of 4. 4 times 3 is 12, 4 times 13 is 52, and 4 times 10 is 40. So I could take out a factor of 4, but I'm going to factor out that negative as well. So here's what I'm going to do. I'm going to factor this by taking out a negative 4b times, let's see, then I would have a 3a square. I would have to have a negative 13a and a negative 10. Now you could check this step by applying the distributive property to make sure that this is valid. So now I have that 3a squared minus 13a minus 10, and I'm going to use the AC method, right, with a equal to 3, b equal to negative 13, and c equal to negative 10. So let's see, a times c is negative 30. So let's find factors of negative 30. Negative 1 times 30, negative 2 times 15, negative 3 times 10, and negative 5 times 6. Finding those sums. 29, 13. Negative 2 plus 15 is 13. Well, wait a second, I wanted a negative 13. So let's change the signs. Negative 2 times positive 15. Oh, I did it again. 2 times negative 15. If I find their sum, that's negative 13, so this is the pair that I want. Alright, so negative 4b, and then I'm going to switch over to brackets now. 3a squared plus 2a minus 15a minus 10. And now we use grouping. So 3a squared plus 2a, that's my first group, plus negative 15a minus 10, that's my second group. From the first group, I can factor out a times 3a plus 2. From my second group, I factor out a negative 5. Negative 5 times 3a is negative 15a. Negative 5 times positive 2 is negative 10. We have that common binomial factor of 3a plus 2. So I can write this as negative 4b bracket 3a plus 2 by a minus 5. And again, we usually don't retain those brackets in the end, so I would write this as negative 4b by 3a plus 2 by a minus 5. And that is the completely factored form.